For this example, we want to find the general solution of the differential equation dx dt is x squared minus 1 times t, and the solution that satisfies x of 0 equals 0. So this is separable. I can move the x squared minus 1 to the other side of the equation and get something that looks like 1 over x squared minus 1 dx equals t dt. I can integrate both sides. On the right, I get t squared over 2 plus c, nice and easy. Now on the left, we have to figure out how to evaluate this integral. And if you think way back to Calc 2, you've done this before. This is solved using partial fractions. So I want to write 1 over x squared minus 1 as something over x plus 1 plus something over x minus 1, because that's how x minus 1 factors. And so we'll have ax minus a plus bx plus b over x squared minus 1, combine the expressions, equals 1 over x squared minus 1. And so I will need a plus b for the x coefficients equals 0, and b minus a equals 1. This is satisfied by b equals 1/2 and a equals minus 1/2. So that means that I want to integrate negative 1/2 over x plus 1 plus 1/2 over x minus 1 dx, which is negative 1/2 log of x plus 1 plus 1/2 log of x minus 1, which is 1/2 log of x minus 1 over x plus 1. In this case, because we are starting at x of 0 being 0, so x is going to start at 0, this absolute value here I can evaluate because I know that I will have x minus 1 being negative, because 0 minus 1 is negative, and x plus 1 being positive. So I can rewrite this as 1/2 log of 1 minus x over 1 plus x, just to make it look symmetric. Okay, now we can go back to where we were at before with this. This was just my integral of the one side of the equation. So what I have is that this equals this. So I have 1/2 log of 1 minus x over 1 plus x equals t squared over 2 plus c. And now I want to try to solve out for x here. To solve out for x, we're going to multiply both sides by 2 to get t squared plus 2c. I'm going to exponentiate both sides to get e to the t squared plus 2c, which I'm going to rewrite as d times e to the t squared, where d here is e to the 2c, it's another constant. And then I want to solve out for x, so multiplying the 1 plus x to the other side, 1 minus x equals 1 plus x times d e to the t squared, or d e to the t squared plus x times d e to the t squared. Put the x's all on one side of the equation. 1 minus d e to the t squared equals x plus x d e to the t squared. Factor out the x and divide by what it multiplies. Gives me that x of t is going to be 1 minus d e to the t squared over 1 plus d e to the t squared. And that's what I get for my general solution. Now, if I want x of 0 to equal 0, that means I want 0 to equal 1 minus d over 1 plus d. So I want d equals 1 to get a solution that is x of t is 1 minus e to the t squared over 1 plus e to the t squared. The answer there might look a little complicated, but it basically just comes out of solving separable equations and then working with the algebra to simplify it out as much as you can to solve it out for an explicit solution, x of t.